In this short video, I'm going to discuss this problem which you are going to solve and submit soon. So here you have a tool which is used for installing and removing snap rings. So the question here is to determine the spreading force applied at G and H if force P is equal to 50 Newton. So intuitively you can actually feel that when you apply force here, so people usually do it by hand. When you apply a force here inwards, the point G and H will spread out and there will be a spreading force. And in this particular case, that spreading force will be vertical, because you can see, as you can see, that this given ring is free in space, so it can move left and right. So it's not possible to apply a net force without any movement. So it's not moving. That means that you can't apply a horizontal force. So vertical force, a net vertical force is not possible either, but since there are two parts, you can apply spreading forces up and down to spread the snap ring. Now let's go to the details of the problem. So this is basically a frame, a kind of frame, and you need to consider each members of the frame, resolve it, find the draw the free body diagram, find the external forces on each member, and using equilibrium equations try to find out the unknown forces, and finally determine the spreading force. So the first thing here you can do is to sort out the geometry here. You can see that various lengths, dimensions are marked here in the problem. So what I would do here is that you can this section here, the triangle like section here, let's try to draw it. So you have CF here. CF is not actually straight, but it doesn't really matter as long as we need to worry only about the dimensions given. It does not matter if it's actually not straight, or if there are some extra decorations or curves or something on the member. It does not matter, because this is completely rigid. We are considering all these members as rigid. We are not considering material properties. We are not bothering about the extensions or deformations of any part. So we would only worry about the given dimensions. So let's say this is CF and this is CD. Now there is a part DE and EH. I would like to sort out this dimension, because this is not a full not a triangle actually. You can see that this So if I draw a line here from midpoint to here. This does not look like a midpoint. I draw it that way because I wanted to show that this is not a straight line. So this dimension here is 16 from here to here, and from here to here, that is 13, and from here to here, that's 3 mm. From here to here, that's 3 mm. Now from here to here, given distance is 16, and from here to here, given distance is 32. Now what I would like to actually show you is that I want to show that this is not a D to this middle E. DF is not actually a straight line. I'm drawing only to show you that. So if this is F, so this angle here is, these two angles here, this angle is tan inverse, this angle is tan inverse 3/16, and this angle will be tan inverse. So this is a right angle, right? This is a right triangle, and this is also a right triangle. And this angle here is tan inverse 13 divided by 32. So that means that this angle is not equal to this angle. Tan inverse 3/16 is a different number, tan inverse 13/32 is a different number. So these angles are different. That means that from D to F, it's not a straight line. I just want to point out that. But this will not make any this will not introduce a lot of complexity to the problem. This is still a simpler problem. I just want to mention that DF is not a straight line. Now from here, this is quite straightforward. So you can consider first this member BE from here to here. BE. So let's say this is point B, and this is E, and this is D. And there is a force P applied here, and BDE, this is a single member. There is no this is not a connected member. BD is a single rigid member, and of course this part here has a curvature, but we don't need to bother about that. We only need to bother about the fact that the P is applied 60 mm away from the D. So this distance here is 60. Now let's try to these dimensions are also given, but it's not really, won't make a lot of difference here. Now if you draw the free body diagram of BDE, one external force here is P, and there is going to be an external force from CD. CD member is pin joined at C and D, and there is no internal, there are no other forces on CD, there are no moments on CD, which means that it acts like a member on a truss. It's pin joined on C and D, and there are no other external forces within the member or moment. So the force on CD and by CD should be in the direction of CD. So there should be an external force by CD on this member in this direction. Or direction does not matter, let's assume that direction. And again I want to emphasize that this is a single member. Okay, this is a single member. This is not, BDEs are not two members, it's a single member. So there is a downward force here, and a moment is not possible because it's a pin joint. Here also you can't apply a moment from EFG on BDE because again it's because it is a pin joint here. Now there will be a force, there is no moment, but there will be a force from this part on BDE. And what will be the direction of that force? We don't know, because both of these members are members have forces that are within the body, not on the joints. So we don't know the direction of force. For CD, we could have easily predicted, we could actually predict the direction because there were no external forces within CD or moment. But that's not the case with member BDE or EFG. Both are complex members with a lot of different types of forces. But it's possible to actually guess that forces, external force on BDE will be vertical. How is that possible? That is possible because there are no other horizontal forces. Even if you assume a component in any other direction, that force will become zero because there are no other horizontal forces. Because when you consider the equilibrium in x direction, net force should be zero. So if there is only single external force on horizontal direction, and that force will be zero because net force in x direction should be zero. Now let's call these forces some names. Let's call this one F1, and let's call this one F2. Now P is equal to 50 Newton. F1 and F2 are unknowns. Two unknowns are there, but fortunately we have two equations. Which are the equations? Net force in y direction is equal to 0, and net moment about any point should be 0. So using these two equations you can find out the value of F1 and F2. You can take moment about any point, but it will be very easy if you take moment about D. If you take moment about D, if you take moment about D, the equation will be P multiplied by P, which is given, multiplied by 60, and that is about D, that is acting in clockwise direction, and it will be positive, Now clockwise direction we usually take it as negative, right? So P into 60 plus and then you have a force F2. What is the perpendicular distance between line of action of F2 and the point D? And that is this. This is the perpendicular distance between line of action of F2 and point D, and that distance is clearly given, which is 16, and it causes a anti-clockwise moment, and it can be taken as positive. So into 16 is equal to 0, so from which you can get F2, and using sigma Fy is equal to 0 you can also find F1. So you have F2 and F1. So once you have F2 and F1, you can consider the equilibrium of EFG. So let's say this is EF, and I don't know what exactly what angle this actually has, but I'm just drawing it this way. It's okay. So this is EFG, and here F2 is the force by EFG on BDE. So there will be a force by BDE on EFG which has opposite direction, so downward force F2, and there is going to be a force by the ring on EFG, and I told you that should be vertical. It cannot have a horizontal component, and I told you the reason for that also. So which is the spreading force, S spread, that we need to calculate. And at the middle there is going to be an external force on it. External means external to this member, so that is the force on the joint from the member CFH. ACFH is a single member, and it will have a horizontal component and vertical component, but like I told you, a horizontal component is not possible here, because if it is if we actually draw it, that will be the only horizontal force, and that value will become 0 if we put sigma Fx is equal to 0. Net force in x direction should be 0. If this is a single force, then that will be equated to 0. So you don't need to, you can draw it and put it to 0, or you don't need to consider it. Yeah. So F2 we have already calculated. FSP is an unknown, F is also an unknown. From here you can calculate both F and FSP, only two unknowns. So the two equations we will need is sigma Fy is equal to 0 and net moment about any point. For example, F is 0. So just the way I have calculated moment equation, here you can find out the moment equation. That's very easy here. Forces are here, and distance between line of action of forces and the point is given, and this force is passing through the point about which you are taking moment, so this force doesn't need to be considered. Just like here, this F1 was passing through the point D about which we were taking moment, so we did not consider it. So here also you don't need to consider it. So from that you will get the value of FSP, which is basically the question. That is the question, determine the spreading force. So that's actually quite simple and straightforward. So I want you to write the answer in detail, very detailed, step by step, with full explanation, and this has a lot of weightage, like I told you, like I instructed you in the class. So if you have any other questions, you can ask me. So if you ask me, could you have calculated the unknown by considering the member ACFH? If ACFH has 1, 2, 3 forces, 3 vertical forces on it, and only 2 equations are available. So it's you can't directly come up with an answer in that way, but of course after calculating one of the unknowns you can go to that direction. So I think here I've given enough instructions for you to fully solve the problem, and I wish you will take up from here. Thank you.